Good morning. Our today's topic is division algorithm for polynomials. I have already shared one video related to this, the basic concept about division algorithm for polynomials. So this is actually part 2. So still I recapitulate this concept, that is px is equal to gx into qx plus rx, where px is a polynomial in x which acts as a dividend, gx is a polynomial in x which acts as a divisor. Then there will be unique polynomial qx which will act as a quotient, and rx which will act as a remainder. So either the remainder polynomial rx will be equal to 0, or if it is not equal to 0, then the degree of the rx must be less than the degree of the gx. So this is about the basic concept, and today we will apply this in exercise 2.3, which is related to the NCERT textbook of class 10th. Question number 1, second part, that is px x is to the power 4 minus 3x square plus 4x plus 5, and gx which will act as the divisor, that is x square plus 1 minus x. So first of all we need to check whether both the polynomial are in standard form or not. So standard form of polynomial I have already discussed in the polynomial basic concept related to the polynomials. So if px, that means standard form of the polynomial is that when, that means actually arranging the terms of the polynomial in decreasing order of the exponents. So here the terms are already arranged in decreasing order of the exponent, that is 4, 2, 1, 0. So that is already in standard form. But the divisor polynomial, that is x square plus 1 minus x, is not in standard form. So first we will write this in standard form, that is x square minus x plus 1. Now this polynomial is in standard form. So prerequisite for dividing the polynomial, any polynomial by another polynomial, that both the polynomials should be in standard form. Standard form. So now I will do the division process. That means x is to the power 4 minus 3x square plus 4x plus 5, which is actually the dividend polynomial px, and the divisor polynomial is x square minus x plus 1. So first of all, to get the quotient, the first or the highest degree term of the dividend is x raised to the power 4. So I will divide the first term of the dividend with the first term, that is the highest degree term of the divisor. So by using law of exponent, I will get x raised to the power 4 minus 2, that is x raised to the power 2. So x raised to the power 2 will act as the first term of the quotient, and I will multiply this whole that first term of the quotient with the whole divisor. So x square is, when it is multiplied with x square minus x plus 1, we get x square into x square is x raised to the power 4, x square minus x, we get minus x cube plus x square. So I will subtract this expression from the dividend. So that is x raised to the power 4 minus x cube plus x square. Now sign gets reversed since we are subtracting this polynomial. So plus x4 gets minus x4, minus get plus, get minus. Now the sign associated to x raised to the power 4 is minus x, which is associated to x cube is plus, and x square will be actually minus x square. So x raised to the power 4 minus x raised to the power 4, this term will get vanished. So this is actually plus x cube. Then we have minus 3x square. Minus 3x square minus x square is actually minus 4. Minus 4x square. Then next term is 4x plus 5. Now this is our new dividend. So again we will divide the first term of the new dividend with the highest degree term of the divisor, that is x square. Again by law of exponent, 3 minus 2, that is x. Now this x will act as the second term of the quotient, and we will multiply this x with x square minus x plus 1. So x into x square is x cube minus x square plus x. So I will subtract this expression from the new dividend, that is x cube minus x square plus x. Now since we are subtracting this expression, so signs will get reversed, minus plus minus. Now plus x cube minus x cube, this term will get vanished, minus 4x square and plus x square. is actually minus 3x square plus 4x minus x is plus 3x and the term plus 5. Now this will act as the new dividend. Again we will divide the first term of the new dividend, that is minus 3x square, with the first term of the divisor. So we will get minus 3. So minus 3 will now act as the third term of the quotient, and I will multiply with minus 3 with the whole divisor polynomial. So minus 3 when multiplied to x square, we get minus 3x square minus 3 minus x, that is plus 3x, and minus 3 plus 1, that is minus 3. Now signs get reversed, plus minus 3x square plus 3x square, this term will vanish, plus 3x minus 3x, this term will also vanish, plus 5 plus 3 is 8. So 8, this is our remainder polynomial, and the degree of this remainder polynomial you can write it as 8x raised to the power 0. So degree of the remainder polynomial is 0, which is actually less than the degree of the divisor polynomial, which is 2. So we can't further proceed that division process. So the remainder is 8. This is the remainder polynomial, and the quotient polynomial is qx. So in exercise 2.3, in question number 1, so we need to find out only the quotient and the remainder polynomial. So first, second, third, second part I have already done. So you can do this question number 1 and question number 2. This is the first polynomial and this is second polynomial. We need to check whether first polynomial is the factor of the second polynomial. So when the first polynomial will be the factor of second polynomial, that is, this acts as the divisor polynomial and this is the dividend polynomial. So if the remainder comes out to be 0, we know that if the remainder comes out to be 0, then this will be a, if the remainder comes out to be 0, then both gx and qx will be the factor of this polynomial. So we need to check whether the remainder is 0 or not. If rx comes out to be 0, then gx will be factor of px. And if rx is not equal to 0, in that case we will say that gx is not a factor of px. So here we need not to do anything more. We need to simply divide the second polynomial, which is actually px, with the first polynomial gx, and we will check whether remainder polynomial rx comes out to be 0 or not. If rx comes out to be 0, then this first polynomial will be the factor of second polynomial. If rx is not equal to 0, then gx will not be factor of px. So we have to do only the long division process, nothing else. So that's all for today. Thank you.